Welcome back to Building Research Relevance. This series is on how we can create better and more relevant research, especially for clinical work. My name is Stephen Shaw. I'm the chair of the Department of Educational and Counseling Psychology at McGill University in Montreal, Quebec. And so this session is going to be a bit about how academic incentives contribute to some of the issues we have with research that's not relevant. And a good example, this came up actually not that long ago and is still really quite relevant, that Peter Higgs won the Nobel Prize in Physics in 2013, I think. And his Nobel Prize was for his big contribution to the discovery of the Higgs boson particle. Some of you probably remember this coming up as a major finding. But Higgs did almost all of his work. Most of it was mathematical in nature, and did most of it between about 1963 and 1965. When he went to get his Nobel Prize in 2013, so, a good 50 years later, in 2013, as he picked up his prize, he said that he really felt at his university, he almost certainly would have been fired if he weren't nominated for the Nobel Prize in 1980. It was if they're going to keep him around in case he wins the Nobel Prize. But the problem was he wasn't really producing very much. He produced his important work many years before and was not producing enough to meet the academic incentives of the era. It used to be pretty well that you could get by with not publishing very much for quite a lengthy period of time, even if you were continually thinking and creating ideas. Those days are gone. Now the publication rates are incredibly high. There's so much more information published than ever before. And as I've mentioned in previous sessions, most of these publications are completely irrelevant. But Higgs' idea, and he spoke about this very openly at the Nobel Prize reception and in other interviews too, he doubts that any big breakthrough could really be achieved in today's academic culture, because there are such expectations to collaborate with others and churn out papers. He actually said, it's difficult to imagine how I ever would have enough peace and quiet in the present sort of climate to do what I did in 1964. I think he's right. I mean, he famously also said that he'd never sent an email, and you got to respect that. I mean, that's awesome. But he believed that discovery requires intense solo effort. And now science has become very much group-focused and very much a collaborative effort. But there is a lot to be said for making major breakthroughs with solo work. And he believed that solo work would help set the stage by creating theories and models, and that tends to be individual work. And that teams or consortia are excellent for testing that work. I mean, the CERN Super Collider is an amazing location, but it's also this incredibly large network of scientists that go about testing things. And eventually they tested a lot of Higgs' ideas and found that it was helpful and led to a big discovery. So you need both the intense solo work to create innovation, but the work on testing things and coming up with ideas is really teamwork. So he felt that what he had to do as a solo smart person was to have time and effort to think about solving this problem of knowledge of where the Higgs, of course he didn't call it the Higgs boson particle, but developing the infrastructure to know this issue. And in some of the language that I've used before, that an individual is very good at helping design what the right questions are, and that answering those questions is work that's really well done as a team. So asking the right questions is actually the discovery. And that's kind of what Higgs was focusing on. However, the academic incentives now are not so much for discovery, not so much for developing the right question. It's for answering a lot. Nicholas Brown wrote it recently in a paper that he said there's no academic incentive to do better research. There's none. We talk a lot about research revolution, but what's the incentive to do it? There really isn't. There's not even an incentive to do careful research or good research. The idea that I have about developing relevant research, that's just beyond the bounds of comprehension when it comes to looking at the academic incentives. What do you get for doing better research? Nothing. It takes longer, and you will not meet the incentives that your university has for you when it comes to merit increases or promotion or tenure. So this is kind of a interesting thing, and I have a few little anecdotes about that. One of my colleagues was discussing some very interesting hypotheses that they had, and I said it would be a fairer test of those hypotheses to pre-register the hypotheses and maybe develop a more appropriate control group for comparison purposes. But that's a harsher test of the idea, and it's a good test. But the chances are that if you did these more careful controlled studies and pre-registered hypotheses instead of hunting for what you want to confirm, that the hypothesis is less likely to be borne out by the data. So the person said, I don't want to do that even though it's a better study, because if my idea is not supported, then I really don't have a career. Well, the honest truth is I don't think you have much of a career anyway if you don't consider that. But I do understand that in terms of academic incentives, it's to publish a lot and even to get known for an idea. That's more important than giving it a good test or a good idea for discovery. Just as another thing, I shared an idea I had with a younger colleague about creating an open access textbook that's sort of a research handbook for clinical trainees with more data, a little bit more on data management and less on infinite varieties of ANOVA. And I still might do that. But the younger colleague asked me, how are you going to make any money on this? I said, well, I don't think I will. And she goes, it's not refereed, so it's not going to count for merit or promotion. Well, that's true too. There's no incentive to do it, but it seems like a good thing to do. But her question was, what's the incentive? What are you going to get out of it? And I see this all the time. I'm serving as interim department chair. And so I'm only going to do this for 2 years and then I'm done. But I have to do the annual merit exercise of all of my colleagues. This is how we get paid at McGill. You get increases based on merit. It's not automatically given. And it's all the formulas that we have for evaluating my colleagues are all counting stats. How many publications, how much grant money, how many students. We have people who publish 18 to 20 papers a year, and those people get the highest merit. We don't really look very carefully at the quality of the journal. That's a challenge. I know some countries have their own ranking of journals in terms of quality, but we don't really look at that at all. It's just publications. So if you publish in Cell, that's the same amount as if you publish in Humpty Dumpty magazine. And so the incentive is to publish a lot. I saw this. You see these 18 to 20 papers a year, which is phenomenal. Usually they're part of a consortium or a team, and they're one author of 40 or 50. That's great. Fine. Good on you. Those are papers that are mostly p-hacked and mostly salami sliced, the smallest publishable unit of data, as we refer to it as LPUs, least publishable units of data. They're not relevant. They're useless. No one's ever going to read those papers, or the only people who read them are other people who write papers who publish 18 to 20 papers a year. And then I saw another study in my group of colleagues. It was probably one of the best papers I've ever read. It was really a field-defining study that was a massive undertaking to do. And I thought it was just one of the most impressive works I've ever read. And guess what? As I'm evaluating merit, that counts as one publication. That publication is certainly going to be more valuable and have more relevance in long term than the 18 to 20 papers that some people are publishing. But the incentives are for producing as much as possible in order to reach that important goal of bringing in as much grant money as possible. The criteria for academic success is now how many grant dollars do you bring in, and secondarily, the number of publications. This is a perfect incentive in a storm to use the least useful metrics there are. questionable research practices such as p-hacking, harking, and so on. That's a big deal. Taking every possible shortcut with your data collection, with your publication method, or even to fictionalize data. There was that really great preprint paper by James Heathers, although it's really hard to make too big of conclusions on the literature he reviewed. But I don't think his estimate of about 1 in every 7 papers has fictionalized data is fraudulent. I don't think that's off. It might be an underestimate. And I can say that because I did work for 11 years as a journal editor with a couple of journals. And 3 times I found the results to be just too good to be true. And I asked the author for the data. And 3 out of 3, all 3 simply retracted the paper. Not retracted, but they took it away from, there's a name for that, withdrew the paper from consideration rather than provide the data. 3 for 3, when the data looked too good, it probably is. But the incentives are so great. Fictionalizing data is a big deal. We're seeing Elizabeth Bick do a lot of her work with, mostly with images, but does a lot of this sort of work, finding that images are just cut and paste or photoshopped or things. It's so much easier to do that, and the incentives are to crank out as much as possible. Doing good work takes time, but all the incentives are for whatever it takes to get the publication or the grant. It's like Wayne Gretzky said about goals. They ask how many, not how. But the how is everything. That's what we do, why we do, and what we do it. Without a how, creating a credible methodology, then there's no true discovery. There's just tedium. Right now, we have a system that's designed to kind of make up for financial shortfalls of higher education funding. And that's the way it works at big universities that tend to be research. It's not a recipe for discovery. It's not a recipe for relevance. It's not a recipe for anything other than repetitive work at the very most benign. Repetitive, redundant, pretty much a whole bunch of meh papers, which is why clinicians don't read papers. That's all they see. And that's the best possible world. We're still talking about fraud. We're still talking about intentionally, let's just say, cherry-picking results or cherry-picking analysis, or in other ways, p-hacking. We're seeing this all the time. And this is just a recipe for making research that's never, ever going to be relevant. And it has nothing to do with the researchers. It has everything to do with the incentives. They're only doing what they're paid to do. And what they're incentivized is to create more bricks and not build houses. And as I call back to that other analogy I made in a previous session, now we're incentivized to make bricks of uneven quality. We're seeing more retractions than ever from journals because we see really poor research. We don't even have strong bricks to build a house of, but we have a lot of them. So that's where we are right now. And for research to be relevant, as I mentioned earlier, we need theories and models that are built on a whole bunch of really good research. Right now, I'm not sure we have good research, and I have entirely to blame for this the academic incentives. You think of, well, what if I leave the university and go into industry? Totally reasonable. But all that work will be short-term and something that can be monetized fairly quickly by your company. Nothing wrong with that, but I doubt we're going to have too much of great discovery except discovery that makes money. So what's my answer for that? I don't really have one. I can say for me, I've given up on having a career long ago. I don't really want to play that game. I have a nice job. I love my work. I don't really care much about a career. People often value it. But I'm really going back to what I consider my first principles as a human. Do the right thing and accept the consequences. And if I'm going to take my time to do things right, to do things in a relevant way, that's great. I have done p-hacking research. You can see it in my CV. It's all over the place. But I have to avoid that now. I would like to increase the likelihood of a Higgs-like discovery. That's pretty grandiose. But to be less grandiose, focusing on methods, minimizing these values of academic incentives as ruling the life of how I do research, and just focusing on doing things right, doing things in a relevant way, rather than chasing merit, careers, or awards. The other awards will be just as successful. You'll just be as well known, as influential, or however you want, But mostly what we want to do is be relevant. And you can chase merit, chase your awards, but your work will always be irrelevant if you simply chase these academic incentives. So that's my, that sounded a little fire and brimstone, a little bit preachy there, but that's okay. I think that's where we have to be and talk about this issue. So academic incentives have to change. If not, those of us who can will choose to ignore them and just focus on the quality of our work, and that's the only way to get to research relevance. Next time I'll talk a little bit about a model that helps us with gaining some relevance and creating good research. Thank you very much, and I'll see you at the next session.